SR latch with control inputs that we are going to see now. SR latch with control input. What exactly the advantage that we are going to get by having an extra control input to SR latch that we are going to discuss. So this control input will have a control on circuit operation, which means if S and R are changing continuously, then your Q and Q bar is gone continuously varying. I don't want that. I want in a controlled way. If I want this circuit to work, it has to work. If I don't want to work with this circuit, I should be in a position to disable it. Okay, so it's like it's equivalent to control input is nothing but an enable sort of thing. So what exactly that means is when this control is not there, that means when control is active low, which means I should not have any sort of output. I'm not supposed to. And if I want to work with this circuit, if my control input is 1, then normal functionality will come. So that is what exactly being shown with respect to the truth table of SR latch. What sort of SR latch that we are dealing here? It is active low logic. How can I say active low logic? What is active low logic? When S is equals to 1, okay? What exactly? Output. When S is equal to 0, what exactly the output? Based on that, we can say when R is 1, Q is 0. When R is 1, this is using NAND gates, of course. When S is equals to 1, output is 1. So is it active low logic? No. Active high logic only. When R is equals to 1, output is 0. So when I ask it to reset, it is resetting. When I ask it to set, it is setting. When both the inputs are 1, that is indeterminate or invalid. This we need to prove. Okay. So this is an SR latch with active high logic. It's not active low logic. We can see that is not a big thing. Whether it is active low or active high, it's purely based on S and R values. S is equals to 1, then if at all I get Q is equals to 1, active high logic. R is equals to 1, if I get Q is equals to 0, it is also known as active high logic. Okay? When you are asking to set, it is setting. When you are asking to reset, it is resetting. That is not exactly the case. Okay? Now this is what exactly the circuit. And for this circuit, what we try to do is, we try to make an analysis. What is that analysis is, how we will get this table. So very simple, right? So we can analyze here by looking into the various values of what exactly known as C, control input. Let's say C equal to 0. What is the input that we are getting over here? If one of the inputs to the NAND gate is 0, how NAND gate works? We have seen. How NAND gate works? So NAND gate operation, let's say AB inputs, Y is the output. Let's write here. AB inputs, Y output. 0, 0, 0, 1, 1, 0, 1, 1. For 1, 1, AND gate is 0. AND gate is 1. So for NAND gate, this is 0. And these are all 1s. Okay. So when input is 0, when one of the input is 0, what is the output? Output is 1. 0 ANDed with something is 0, complement of this 1. So complement of this is 1. What is this latch? What is this circuit? And when one of the inputs is 1, okay, what exactly this part? We need to look into it. Okay. So when both the inputs are 1, right, what is going to happen? When both the inputs are 1, so let's suppose presently Q value is equal to 1. Let us assume that 1, 1, 0, 0, 1, 0's complement is 1. So what exactly that is going to happen is, whatever is there for 0, S doesn't matter, R doesn't matter, there is no change. That means whatever it was stored with. I have assumed that there was a 1. When there is a 1, there is a 0. So here I am giving 1 1. Okay. If this is 0, I am getting 1 1 here. Doesn't matter whatever may be the value of 1 or 0 here, 1 or 0 here. That's why it is don't care, don't care. Where C is 0, S don't care, R don't care. Okay. No change. What is the meaning of no change? If Q, that means this value, if it was at 1, it will continue with 1. If at all it was 0, it will continue with 0. That is the meaning of that. That means which is no change. That means whatever previously stored value, assuming that in this case previously stored value is 1. So if this is 1, 1, 1, output is 0, 0, 1, 0 ANDed, 1, 0 NAND operation. 1, 0 NAND operation is 1. So this is 1. So I have assumed 1, I got 1. So there is no conflict. That is whatever the value it has, it is reinforcing the same. That means it was 1, it is also 1 coming. That means there is no change. Okay. Similarly, we can discuss this further with SCC is equals to 1, C being 1. So let me erase everything to start with the discussion, further discussion, so that you will not get confused with the things that we have written already here, and everything will be clear. So let's do the analysis of this circuit for a new set of inputs. What is that new set of input? C equal to 1. What is C? Control input. What is the value that we are giving? 1. So when input is 1, S is equals to 0, R is equals to 1. 1, 1. 1, 1's complement is 0 here. 0, 1, 0. Or this is 1 and this is 0. When one of the input is 0, to the NAND gate, output is 1. 1, 1. 1, 1 is 1, 1's complement is 0, that is NAND operation. 1, 1, output is 0, so this is 0. So I am getting for 1, 0, 0, for what exactly we need to do? Are we looking at 1, 0, 0? No. We are really looking at a 1, 1, S is equals to 0, R is equals to 1. Now when we are looking S is equals to C equal to 1, S C equal to 1, S is equal to 0, S is equals to 0, R is equals to 1, R is equals to 1. Now what we got? 1, 0 output from NAND gate, from NAND output table, truth table. Once again I am using NAND truth table. When one of the, I don't know what is this right now. I don't know what is this. I am not assuming what is the right now output. I am not anything assumption I am making. Just I know one of the input. From this I am trying to get the calculations. Okay. So when one of the input is 0, I need not look at the other input for NAND gate. Output will be 1. So I got 1. The same thing being fed to this NAND gate. This is already 1 and this is being 1. 1, 1 is 0. The same thing being fed over here. This is 0, this is 0, this is 1. It was 1. Now it is also 1. It was 1, it is also 1. That means there is no change. And in the sense, I am getting the final value of 0 and 1. So 0, 1. What is 0 and what is 1 is Q is 0, and Q bar is 1. So when R is equals to 1, I am getting what exactly known as reset state. Similarly, we can analyze 1, 1, 0. Before that, what I try to do is, I will keep this 0 as it is, I will make this 0. Okay. So because of that, what exactly happens is, this is 1 already, this is 0, 1, 0 is 0, 0's complement is 1, this is also 1. When this is 1, what is my output earlier? My earlier output is 0, 1, 0, 1, 0 is 0, 0's complement is 1. So I am getting 1, 1, this is 1, this is also 1, 1, 1 complement is 0. So is there any change? No change. So what I did is, I have applied C equal to 1. I have applied C here. C, S, R, Q, Q bar. If I make an input of 1, 0, 1, output is 0, 1. If I make C equal to 1, S is equals to 1, S is equals to 0, R is equals to 0, but simply I changed R to 0. It was 1, now I made it to 0. So S is same thing, no change. R I have changed it to 0. Then if you look at it, still there is no change. That is same thing. That means even I change the R value from 1 to 0, there is no change. That is for 1, 0, 0, I am getting 0, 1. What is the meaning of that? I have proved that 1, 0, 0 is a no change case. To prove this case, what I did is, I gave this input, then I gave this input. Second, next I gave this input. Next what I try to do is, I will give this input. What is that? C equal to 1, S is equal to 1, R is equal to 0. Then I will give, next I will give 1, 0, 0, 0. That means the combination that I am looking for, I set it by making S is equals to 1, R is equal to 0. S, R. Now what I do? I will make both of them 0, 0 by keeping C equal to 1 always. C is not going to change, but I will ask it to set, then I will make it to 0, 0. 1, 0, 0 case is no change case. I can prove for two cases. When it is in reset state, it will be continue with reset state itself if I apply 1, 0, 0. If it is in state state, even if I apply 1, 0, 0 after state state, it will continue in the state state itself. If I give 1, 1, 1, what is that 1, 1, 1? Let's discuss that. So for 1, 1, 1, let me take the eraser and clear everything. Clear everything. Then we'll see. What is that we are looking for? Let's look at the last entry of the table. What is that last entry? What exactly that we are looking for? Let's make an analysis. Okay. So this is 1. Let me take the pen. This is 1, this is 1, and this is 1. 1, 1, 0, 1, 1, 0. Then, if one of the input is 0, output will be 1. For an AND gate, if one of the input is 0, output will be 1. I need not look for the other input. Okay? So, without looking at the other input, I can say both are 1. So, what exactly I am proving? Q equal to Q bar I am proving. Is it possible? Not possible. So, indeterminate or invalid. Invalid input. S is equals to 1, R is equal to 1 is invalid input. Okay.